Okay. All right, there's this. It's something like although actually I don't want this spectrum really wants. All right. Okay. So I'm gonna come up later in the day. No, I probably should have put this all on a compliment. It's for the sake of having the flexibility. All right. What else am I forgetting to do here? Oh yeah. So put this in. Mm. It's a little bit layout. And oh, uh, 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 yeah, we'll get there. All right. Uh, I can get it to vote with me. No, thank you. No, these but so what was so we needed to finish the last section. What was the last problem that we did? Say?
Yeah, it was the one X it was X equals 1/3 squared. I mean X or X minus X.
Okay, 1/3 to the x bar. And did we get all the way, we got all the way through that graph, right?
Alright. Yeah, oh yeah, we did.
Then to finish off this section, so in this section, they wanted to give you an application of exponential functions. And this application is one of the most common, well, I would say common real world applications if you're not in chemistry, you're basically not in, and it's compound interest. So whenever you put some money in a bank and they give you interest on top, they're almost always doing compound interest. But especially whenever you take money, you get a loan from a bank, you get a loan for a house. Basically, literally all loans right now for that are cars. Cars are still what's called simple interest, on exponential function. Everything else is compound interest. So we're gonna kind of look at this equation and look at a problem in the book to kind of help work our way through using this equation. Let's see. Yeah. So. And we'll kind of, as we go through this, you'll kind of see part of the reason I want to do this. So there's just some interesting patterns. There's some interesting things that happen with compound interest that wouldn't expect. So, but the way compound interest works. So I'll write the formula for you guys and let me just explain what each part means. So this is your basic compound interest formula. So P stands for principal. It's basically the amount that you begin with. I want to write that one in. Yeah, it was kind of, we'll say beginning. So practically this, especially if you're getting a loan, this is the amount that the bank gives you, or whoever gives you that you're getting the loan. A stands for amount, but it's really, this is the ending amount. So this is the amount you actually owe by the end of the whole time you pay your days loan. R is your interest rates. N is the number of times per year. So then it's the number of times they charge interest per year, per times. Interest per year. And T is the number of years that you took that loan out for. Alright. So. To kind of flesh out a lot of what this means, so let me step it. I'm gonna pull up one of the problems from the book. It also kind of looks, at least it looks decently similar to to the same setup you guys are gonna see as well. So, but, I'll go over that. Leave scoop. All right. Where's the computer? That's interesting. I said, you know, I'm specialty. Filter. I did. There we go. You go through. Yeah. All right. So we're gonna look at this problem here. I'm gonna slightly alter the context on this problem though, so. On 45, it says, suppose $10,000 is invested, we're gonna suppose that we get a $10,000 loan. So we get a $10,000 loan at 4% interest for 5 years. Kind of give you under the bond compounding options. So we're gonna calculate how much we owe at the end of this loan, at the end of 5 years. Based on whether they charge you interest annually, quarterly, monthly, daily, or continuously. So let's work out a couple of these as a class and we'll have you guys run a couple of these yourselves. So let's say they charge you interest annually. So annually means how many times per year? Once. So what they're saying, so when they say they're charging you interest annually, what they're saying that is, in this case, at the end of every year, they're gonna charge you 4% of what you owe. So for instance, they give you the loan to begin with, they give you $10,000, then a year later, they're gonna charge you 4% of $10,000. And they're gonna add that on to what you owe, and now you owe $10,000 plus whatever that 4% is. But then if you think about it, so the reason they call this compound interest, what they do at the end of year 2 is they now charge you 4%, not of $10,000, they charge you 4% of 10,000 plus the interest they added on. So they charge you interest of interest. On top of interest. And so then and they add that on, and then at the end of year 3, they're gonna do 4% of the new total amounts, including all the interest they've charged you. And add that on, etc. So that's kind of what we're looking at. So commonly, very rarely anymore do you see something that's annual, it's usually either quarterly, monthly, or daily. But let's work the annual calculation takes days. So if they're gonna charge you this annually, what am I plugging in for the beginning amount? What is that thing? What would you guys plug in? So just start feeding me information. It should. So. Well, no, so I need, based on this, based on what they're telling me here. P is the amount you begin with, so the amount, in this case, you take out a loan for. So what's P in this case? 10,000, so I'm gonna plug in 10,000. Then 1 plus, what's my R, what's my interest rate? 4%, so I'm gonna turn that into decimal version, so 0.04. And then if we're gonna do annually, you guys said how many, N is the number of times they charge you interest, so how many times is annually? One, so I can put a 1 in for N. And how many years are we taking this loan out? 5 years. You're just gonna plug in the information they give you. And run this through your calculator, kind of see how much we owe at the end. So I'll give you guys a second to run this, work this through your calculator, unfortunately.
Glass,
Anyway,
glasses, but.
not that, I mean, yeah, I didn't see him.
That's things.
I just keep forgetting.
Oh, yeah. People. Or. She was working with him. I'm trying to wait on that exhibition.
All right, so what are y'all getting calculation?
Yeah, we'll go through slides.
Yeah. 12,166 and yeah, 53 cents, rounded at least. What about any trouble with that calculation? So if they compound the interest 1 time per year, the results, you owe them 12,666 and 53 cents. So I want you to think about this for a second then. So how much interest did you end up paying on this? 2,166. Even though this was a 4% loan, right? The interest is 4%. The 4% per year, but they're doing, again, what happens is they're doing 4% of 10,000 the first year, and then 4% of that new amounts with the interest added on the second year, 4% of all of that the third year. So they literally are not charging you, so they're not charging you interest on on the amount they lent you, they're charging you interest on the total amount you owe, including the interest that they themselves have added on to your loan. So overall, like roughly
what interest, like what percent did you actually pay on the loan? If you guys don't have an answer, give me a second, let me kind of go a different direction. So you guys are going you're just not answering the same questions as the last class answered. That's okay. Let me figure out where you guys are. No worries.
Well, let's kind of move on to the next scenario. So the next way that they could do this, actually, I need, let me rewrite this. So this is if they're gonna charge you 4% interest at the end of each year for 5 years. Where's my errors? Why do none of these rooms have all shit? Did I put them back? Snap. So as far as like when you get loans, nobody ever gives you a loan with annual interest. So another possibility is that they charge you interest quarterly. So I'm trying to think about the word there. So how many times per year is quarterly? Yeah, so it seems like it'd be 25, because 25 cents. How many quarters are in a dollar though? So when they mean quarterly, they actually mean four, or you can also just think about the fraction. 1/4 is something you split into 4 even pieces. So the next way that they might do this loan for you is instead of 4% once, what they're gonna do is they're gonna do 4% overall for the year, but they're gonna chop it up into 4 equal parts. So 4 times a year, they're gonna do 1%, basically. 4% divided by 4. So they're gonna charge you 1% 3 months in. So let's say your year starts at January, they're gonna charge you 1% of the total in March, and then they'll do a 1% in June. But again, now that's not 1% of 10,000, that's 1% of 10,000 plus whatever they added on in March. And then they'll do September, and then they'll do December, and then they'll keep doing that every year. So give me your thoughts. Do you guys think then that you would end up paying back more money, less money, the same? What do you guys think? Are you saying more? This. So tell me, how would you fill in this compound interest formula for everything the same except for we're doing 4,000? How would
Instead of the main.
change n to 4? So everything else is gonna stay the same. We're still borrowing $10,000. We still have 4% interest per year, overall per year, but now my n is 4. So like I said, they're gonna actually just gonna charge you 1% interest every time, but they're gonna do this 20 times. They're gonna do this 4 times a year for 5 years. So at least that's the curiosity for me is it more, is it less? So let's see. Go ahead and run that calculation. Let's see what we get.
What did you get? Did you? What did you get? Is that what you? Okay, so what? So like you put 20,000 for the same.
Oh, wait. No, I did. Go back.
Wait, I shouldn't read them. The reading is here.
No. I think you're right.
Oh, wait. Oh, wait. No, and if it's. They're paying what? Into the. Where is it?
Oh, I think we go back. We can round it up though.
You can really get some.
For me to get everyone first.
Put 4.5. Because I thought this was a challenge.
All right, what are y'all getting for the calculation?
I got well, 1,000. No, 12,201 dollars and 90 cents.
So if they charge you 1% 4 times a year, it ends up being 12%, 12,201.90. So how much more money did they get off of you by charging quarterly versus annually? Yeah, so they got 2,200 or 2,201 before they were getting 2,166. Yeah, so roughly $40, so like 35.
Yeah. Oh,
Now, is that a big deal to you? Like, just don't be afraid of your answer. You always like say something and then you're like, oh my goodness, no, like I didn't mean that. And it's like, just tell me what you think.
I mean, you do a lot with $35.
True. Yes.
Yeah, that's half of my profit taking.
True. Think about it from their side too. So $35 for one person, but how many people do they have taking out these loans? Likely, or what do you guys?
Sorry, like.
Give me some energy, like you're
I'm
like
thinking,
not,
I'm thinking,
you
I'm
just want to
thinking.
sit here and like hear somebody talk and just like write down some shit, like that's not what this is about, like. So think about it from their side, they're a business, $35 from one
Oh,
person, but how many
yeah,
people do
no.
they likely have taken out these loans?
I mean, I would honestly, if I was in business,
Yeah.
I would do the cheaper one.
Yeah,
Yeah.
well, so, yeah, so if you're taking out this loan, you obviously want them to do it annually.
Yeah.
And so, but I will say any more no business gives you annual interest.
Also, I do work.
Yeah, so then, because, again, if you're the bank, you get an extra $35 out of the person for doing it quarterly. So notice kind of part of what's happening. So if anybody has any experience with business or just knows, like, maybe has some family that runs business. Usually to make more money as a business, you've got to change your product, you got to do an extra thing. You basically, you got to offer something different, you got to do something that costs money. You got to invest capital, you got to pay workers. Notice that for the bank, they've gotten an extra $35 and they've done nothing. All they've done is change the terms of the loan. They said that they're gonna charge you interest 1%, but 4 times a year instead of 4% one time. So they've gotten money essentially for doing nothing. But that $35, if they have 10,000 people taking these loans, suddenly that's $350,000. So they just got an extra $350,000 in profit for literally doing nothing. Just for changing how they calculate your interest. Just do it. Yeah, it's an absolute, it's a complete hustle. I was telling the last class, one of the things my dad said a lot was, he was like, oh, you don't see the mafia around anymore, right? And he's like, they didn't die, they just went into insurance and banking. This is just a straight hustle. This is them getting money for nothing. And unfortunately, like you're saying, so like it would be nice as me, the person coming to the bank, or even a business coming to the bank, that I could choose annual, but they don't ever give you that choice. So it is just a straight hustle. Yep. The legal hustle. So if you go and you get the degrees and you start working at the bank, and you have the capital to start a bank, you can legally make this hustle. Yeah. But now, talking about, you kind of have, unfortunately, you often have no choice in these things. So when you get a loan, you're actually still rarely ever going to get it. So businesses can get it quarterly because they do. Businesses usually take out a lot larger loans, and so the bank wants to encourage that. So businesses will get it for quarterly, but as consumers, it's just, single people, you will rarely ever find a loan at quarterly interest. Maybe at a credit union, because they're usually much better about trying to get a better deal for people. Almost exclusively, all the loans that you're going to take out are monthly or daily, monthly interest or daily interest. So monthly, how many times are they charging you interest per year? 12. And then daily, how many days are there in the year? You're doing 65. So most loans that you're going to take out on big objects are monthly. Credit cards are daily. So now that you guys kind of have an idea of how to run this calculation, I want you guys to take a little time and calculate how much you would pay back on this loan if it was charged monthly, 12 times a year, and daily, 365 times. See what we get out of this. Right. Anything out here.
The trains.
Oh, okay.
Yeah, so I took 96 of those. I didn't give him back. And then I accidentally gave him that shoe. Because somebody was, no, it's because somebody put it on this. It's really part of that person. I'll let you know that about it.
Okay.
Ready?
No,
Just tearing it. 5 seconds.
I'm not.
More contact.
No,
Like we tried the colors,
no.
which tried.
But it looks scary. It's thinking of getting us. Right.
Yeah, like.
You're welcome.
Hey,
Yeah.
we're gonna see a song.
Oh, it's
Oh.
good.
You get enough?
No,
Right.
I did, but it's been a long, bro.
Our goal. Judgment. Judge it. You see my phone. Bro, I didn't get to put in the paper.
You should.
For sure.
I don't know.
Is that? Yeah.
Okay.
This year?
This year.
No, I passed my reading. This is a press on.
I was so close.
Can I have a batteries on?
Look at you.
Bro.
See what y'all are getting. So for the monthly calculation,
That's tough.
That's.
the monthly calculation, this looks like the same thing except for 12, wherever n is. And what did y'all get out of that?
$12,209.97.
Yes. That should have been 12,209.97. Did anybody have trouble with that calculation? Alright. So they made another $8 off of you by doing monthly versus quarterly. Yeah. Exactly. But again, do that for 1,000 people, 10,000 people, that's just auto profit for them. So again, for individuals, you rarely see quarterly, it's always either monthly or daily. So when you take out a loan, it's gonna be monthly, almost always. When you put something on a credit card, the interest is daily. So then on a credit card, That was 0.04 divided by 365 and then raised to whatever 365 times 5 is. What did y'all get as that?
12,213.89. I accept.
Yeah. 213.89. Yeah. So a little more, just under $4 more than they got up. Any questions about those calculations?
Let's take equation to help.
Yeah, okay, good. So I mean, that's part of what I'm checking is just that, so I've had classes that really have trouble using this equation. So it's just more, you guys have to understand, like even like on Tuesdays and Thursdays, I teach the same class three times. You know, but it's interesting how different each class is. So there's usually a class that has no problem using the equations, and then usually a class that has a lot of problems plugging everything in and running it through a calculator correctly. So when I'm asking you those questions, I'm just fishing to see where you guys are, so I know if I need to help you guys with that. All right, so let's look at continuously. So there's also such thing as continuous interest. What does continuous mean to you? What do you think they mean here?
So the 5 minute build.
Yeah, kind of until the 5 years is over. How many times per year does continuous mean?
I think 365.
So maybe it's 365 or every day, but actually we already have data. So surprisingly, it does mean something different.
35.
No.
Hourly?
So maybe hourly, but maybe every minute, every second. So the idea of continuous is they're trying to say theoretically every moment of existence from now until that 5 years ends. So the n is not 365. What they're trying to say is basically your n here is not 365. It's however many moments of existence we have now 5 years. It's technically infinite. You're trying to chop it up into finer and finer, you know, minutes, seconds, whatever. What they're basically trying to do is what happens. We're trying to figure out what happens when this n basically goes. You do this. You divide the rate by infinity, but you also do it in an infinite number of times. And the thing is, so mathematically with this formula, that's actually not possible because you can't divide a number by infinity. And then even worse, how do you raise that to the power? But the interesting thing is in calculus, we can show that this formula, when you want continuous, so we can prove in calculus that this formula becomes this form. And this will give you, even though it's physically impossible to calculate interest, like at every moment of existence, this would actually give you the calculation for it, if you could do it. So this is, notice, similar, but definitely some differences here. So you still have the end amount, you still have the beginning amount. This E here is the natural number, what they call the natural number. Natural number actually comes up a lot in biology, chemistry, physics, finance. It's sort of this like secret number to the universe that basically determines how things grow or how things decrease. So it's the natural number, which you're just gonna find on your calculator raised to, and the power here is now not n times t, it's r times. It's your interest rate times the time, the number of years. So, for instance, for the continuous one, what we're gonna do is we're gonna plug in 10,000 times e to the 0.04 times 5. So what does that give you at the calculator?
All right, what are y'all getting for this?
1,214, you said.
Yeah. So theoretically, this is actually the maximum they can get out of you. Compound interest wise. 12,214.03. I think continuous interest is basically like, not only here, but I think most of the country, they've made it illegal to do. So. Cause it's basically it's the biggest hustle they can make. It's the most way they can take advantage of you. And it also doesn't make sense for reality. They can't physically charge interest. Time intervals. Can't really do this. So that'll finish off the one homework from last week that I pushed off for this week, so that's due Wednesday night, but that's kind of the rest of what they want you to be able to do. Any questions there? All right, then let's kind of turn over to, so we're gonna start looking at what are called logarithms. So basically you've got to do 2 sections in one class in 30 minutes. So try to get this all done. So let's see, what do I want to start with first? I guess we're gonna wait till. Okay, well, let me turn these off. Hmm. All right.
Yeah, remember. Okay.
I think the way I want to. We want to go back and grab, so I want to go back and grab this. Let's see, we're gonna talk about combining inverse rates. I want to take the 2 things we talked about last week. This, not just mixed sentence, but really sort of do both. Then I'll show you why we're doing, where that gets. But what I'll have you guys do, first thing is, I want you to go ahead and graph 3 to the x power. So take a minute to do that. Most of y'all in there, so it's gonna be skip. Or what X values Josh is? And then what did you get for? Mm, yes. Point three three, yeah, so that's like. Good. So then let's scrap that out. So it's 2, 9. 1, 3, 0, 1, 1/3, 1. So how did it go? Yeah. Yeah, so we're never gonna touch the x-axis there, and then it shoots up. Scores on the last page. If you see that line, it's not really hard to. All right, so we know our ninth dimensional function, we can graph it. We also know that, so think really quick about this function, is it 1-to-1? So there's no repeats in your x values, is it also 1-to-1? No repeats in my y values, either. Which means this should have an inverse. So there should be an inverse. So. Color here. Should be inverse. So we completed looking at inverses and how to find them. Actually a little more than they. So give me some ideas then, how could we find the inverse of this function?
We just simply just please.
So since we do see the coordinates, we could just flip the coordinates. So again, this goes back to we're finding the inverse. Even without the equation, it was nice because as long as we had the graph with coordinates, inverse just means switch your x's and your y's. So we could physically graph the inverse of this very easily. So that's the first thing I'll have you guys do. So just take a minute, graph the inverse of this function.
What was the news announcement today?
So let's see what you guys do. So what would these points be?
One.
Good, that's values are 1, 9, 1/3. 1, 3, 9, and then what are the y values? 2, -1, 0, 1, 2. Now, sort of my y values are those normal, that value they normally choose for x. So let's graph this out. The inverse looks like this. So 1/9, which is really close to the center, but again, not going up or down, but actually to the right. So just a skosh to the right of 0 there, then down -2. And 1/3 down -1. 0, 1. Or 1, 0, sorry. 3, 1. Go all the way up to 9. And how would you feel like that? Yes. Yeah, no, you're exactly right. So it is literally, we talked about this with graphs of inverses, that it ends up they're always just flipped across that right boundary line. So it is reflected right through. So through that, so it's gonna look like this. So now, instead of basically the y value never getting to 0, now your x values never get to 0. So instead of having a horizontal asymptote, what type of asymptote does this graph? Vertical. So there's this visible vertical line right along the y-axis that the inverse of the exponential function never crosses. So this is the inverse of 3 to the x. So it's nice that we can see it. We can make it. But one problem with this is like, again, like we see the thing, but we don't have a formula for it. So we also talked about when we were doing inverse functions, one of the last things we talked about is if we have an equation, we can also make the inverse out of it. So we're not going to make a different inverse next, but what I'm saying is we have the equation, we should be able to flip the equation around and figure out the equation for this inverse is. So that's the next thing I'd like you guys to try doing for a second. Are so our original equation is y equals 3 to the x power. We want to see if we can make the inverse of the equation. So we know what equation, right? So I want to give you guys a couple minutes to see if you can make the inverse of this equation.
Let's see what is.
All right. All right, let's see what y'all are running. So find the inverse of your page, how you start out. Go ahead. Yeah. So remember, the first thing you always do with an inverse is you switch your x with new ones. So you switch it to x equals 3 there. But then we need to get y by itself. So you're right. So this makes the inverse, but in order to write it in this form, we have and y equals, we need to get y by itself. So from here, how do you think you get y by itself? What's the vantage on your basis? That is correct. So the thing is, so to get y by itself, we usually have to do the opposite of the operation you see there. And unfortunately, this isn't 3 times y. If it was 3 times y, we could divide by 3, but it's not. It's 3 to the y power. So this is just really weird. This is a really weird combination here because there isn't really a, like y is the power basically, like we talked about, like we talked about last time, that the thing about exponential functions is now your variable is your power. So y is power in Logarithmic. So historically, mathematicians ran into this. So the thing about this is there is no way to actually get y by itself here with the operations that we do. So historically, mathematicians ran into this and they looked at this and said, well, I don't have a way to do this, but I know the thing exists. You can graph there. So often what happens, so when mathematicians or whoever runs into something that you know exists, but you don't have a way to do it or represent it, is we make up a symbol for it, right? So pi exists, but we don't know the exact values. Said by pi. Square root of 2 exists. I can cut a piece of board to exactly to that length. but I can't get the decimal exactly, so I write square root of 2. So we write symbols for things that know exist, we just don't have an exact play for them. So they ended up doing the same thing here. They kind of looked at this and said, well, it exists, but I don't have an operation that gets me there. And so what they did is they rewrote this as so they rewrote this as y equals log base 3 of x. So this log stands for logarithm. So they literally invented the word logarithm, stand for the inverse of exponential functions. And it was their way of now, so literally what I did here is I used log, so I took the base for the exponents, I put it as my base for the logarithm, but they write that as a subscript. And then I just switched the x and the y with each other, essentially. Because when you make an inverse, switch your x and y, so it follows what they know, kind of what we know for inverses, what they do. But this gives us a symbol that stands for the inverse, since we don't have an operation that actually gets us there. So that is what a logger. So the equation for what we see here is log base 3 of x. Well, when you do a logarithm, so again, with an exponential function, x is your power, x here is actually the results for each. So it's you're switching the role of the power and the result. That's what an inverse is, you're switching those two. So that's where logarithms come from. They invented it a while ago, but literally it was just looking at something like this, knowing that it exists, but not having mathematically a way to actually do it. So they invented some words that does it. All right, so that's a good start on logarithms. We will finish. We're actually literally going to finish about most of the 2 sections on Thursdays. When we come back on Thursday, we're going to work pretty through it. But we'll finish the rest of the logarithms Thursday. But they didn't give you like a batch to get into something.
Oh, no, I haven't actually, I could probably get one, but, most of the offices or most of them were just offices.
Yeah.
Some of them are still classrooms, but I'm getting back to, I'm probably gonna have to get back to. To getting to that, yeah.
It's cheaper.